Assalamu alaikum, brothers and sisters. This is the third class. This will be on vectors. This will be for vectors. And simple vectors, brothers and sisters. You want more complex, you have to go and study. And I recommend, if you have no knowledge of this, that those simple books called like Science for Dummies or Physics for Dummies, Calculus for Dummies. Don't feel bad. I've read them, right? When I want to get the first, I want to go and find out how they use, these tools are particularly used, and find out how to use them with their method, right? So there's some good examples in there. Anyway, I'm showing you how you use it, showing you tools, and give you an example how you use it in your life, right? So let's move on, brothers and sisters. Here. And simple vectors. But first, just a recap. You know, we talk about derivatives. That's in calculus, right? How does that affect you? I gave you some examples, but let me. Okay, you see on the right there, that's the cube. On the left, that's a derivative for a cube. That's the basic derivative, because derivatives in general is just going down one dimension. So third dimension down to second dimension. That's what derivative is. Going from, derivative means you're going down a dimension. So if you take the derivative of the third dimension, you're going to get the second dimension. Take the derivative of the second dimension, you're going to get the first dimension. Take the derivative of the first dimension, you're going to get a point. You can't go any lower than that. Okay. So understand that. So the thing is that if that on the right represents our reality, that means the total universe is three-dimensional. So if that represents the universe, the reality, total reality universe, then that on the left would represent the derivative. But we are right now, energy deprivation. See, right now we live in derivative reality because of spatial, because of excuse me. Oh, hold on, I got my voice processes. Oh, well, must be something going around like allergies or something. Energy deprivation, right? So we have enough energy to main. So our mind's reduced to. So right now we're living in derivative reality, and that's just not just saying that, bro. So we're living in a derivative reality. So I'm gonna explain a little more in my normal presentation today, but understand that. I'm trying to show how to reflect. So if you live in derivative reality, that means your whole perspective, mind, everything is limited. The reality you live in is a derivative reality. So I'm going to talk more about that later. And then we're talking about pressure. Well, pressure actually is collisions. See, it's the language they use, but pressure is collisions, it's also time, it's also temperature. All these are components of pressure, right? Attributes of pressure. Temperature, volume, and collisions. Collisions actually, that's really the essence of the pressure, right? But I'm talking about volume. Okay, now volume means the earth is not getting bigger. So like an elevator, you have an elevator, the more people you put in the elevator, the more pressure is going to be on everyone. So the more population you have, the more pressure is going to be. That means the more pressure it is, right? You understand what I'm saying? The more you stuff it, and the pressure is going to increase. So more interreactions, right? And the weaker one is going to be crushed in that situation. If you have little children, they're going to be crushed. If you pack it in, right? Understand these things, brothers and sisters. I'm trying to get a basic idea how it applies to you. So the earth's not getting bigger. And it gets more complicated. I'm just giving you a simple version. Because it gets more complicated when you're talking about resources. And basically, if everybody needs an apple a day to survive, and you got 1 billion people, but you only got 1 million apples, what's going to happen? You got people fighting for those apples. You got a war. Because they would have to have one. And so everybody's going to fight to get, and the ones that don't get it, right, what happened to them? See, these are aspects of it. I'm not going into that kind of detail. I'm just trying to show you how this applies to you. Population matters, right? Resources matter. All that speaks to pressure. Right? And then material matters. Now I explained to you that we have excuse me, boy, yeah, we have a derivative man. We made that, and actually that's what they are. Those are derivatives of us. See, I didn't go, like I said, it's a whole lot. I didn't go into that kind of science. I'm not going too deep into it right now, because if you don't understand multiplication division, you ain't gonna understand this. Understand this? They're actually derivatives, and we understand on the calculus level a lot of stuff makes a lot of sense, but you don't understand on that level. That's spelled spatial correctly. Let me look at that again. Make sure I got everything spelled correctly here. Yeah, it's spelled correctly. Because I'm talking calculus now. Right? They're actually derivatives. That's why they have the structure, but they don't have it. Like I said, they have the what they say, they have the image of us, but not the substance, something along those lines, right? Because they're derivative. Right? And so I take you another level of science. I'm not going to go on, because I know I've probably lost you at this point. I can't take you much deeper. But I told you a whole lot I haven't told you, because you don't understand the basic stuff. But they're derivative. Actually, I'm not just saying that they are a derivative. That's what a grafted person is, that derivative. Right? And if you understand derivatives, right? Okay. So what happens is that, see, because since they're derivatives, that means they have less structure than us. So when a derivative meets the original, is crushed. So they're like glass and we like steel. So they may look like us, but when they collide, they don't survive it. It's totally, and that's what's about to happen. This war, apocalypse. See, apocalypse is the whole war. Armageddon is just a phase of it. That's the European side of it. Apocalypse is just Armageddon is just the European aspect of the apocalypse. When Master Muhammad make his move, he's going to trigger the apocalypse. And in many ways, the apocalypse already started when uh, abominable desolation, right? But it'd be in full force when he makes his move, and then that triggers Armageddon. Okay, I'm trying to show how it just applies to you, because the thing is, when you go to school, those who haven't went to school, they give you math, but most black folks do much math. First of all, they teach it left-handed. And if you're in a reality, everybody's left-handed, but you're right-handed, but you're forced to use your left hand, you're gonna be at a disadvantage. Everybody's gonna beat you up because you got to use your weakest hand. They're using their best one, and that's what it is. They're teaching you their level, and so it's complicated because they have simple minds, so they complicate everything. When I showed you calculus is very simple, but they complicate everything because they have simple minds, and so they teach you on that level, and you say, man, you don't get it because it's so complicated. And then you say, well, how do I apply it? They call it applied science, applied math. How do I apply it? Right? Why do I need to know economics? My father ain't and my mother and father ain't on Wall Street, because they go and learn and apply it on their level, right? They don't apply it as to how it affects them personally. They don't, because they don't see it that way. But they go and the way they do apply it is the economics, control of us, that kind of thing, right? But a child says, okay, like you say, false Israel, right? Their father's a financial expert. And so they see, man, they booked around, they got a yacht, they got a mansion, they got all this stuff, because daddy bringing them the bacon home. Why? Because he's using all this calculus and tensors and other applied math, conceptual mathematics. And so they see the benefit of learning that stuff. Because now I could do that. If I learned, I'd be able to do that too. But you're sitting there, what do I need that for? I'm over here in the ghetto, I'm riding a bicycle, dad may be in jail, mom working at Burger King. What the hell I need to know about calculus for? What am I do with it? See what I'm saying? So you don't have the motivation, and plus it's complicated anyway, so what the hell I need to bother with it? I don't know how to apply it, and it doesn't make any sense because it's the way it says it's complicated. And I saw right away how the simplicity of it. And I taught my children calculus and stuff when they was children, 7, 8 years old. Because I said that way teaching is wrong. Well, that's for them. That's what works for them. But it's very simple. So I'm gonna go. So I just cover that, and then I'm gonna go into clip it. Okay, vectors. Remember, this is simplistic. Like I said, you want to get more complex, you got the basic idea. Now, A plus B plus C is the formula for calculating vectors, right? A plus B plus C squared, A squared plus B squared plus C squared is the formula for calculating vectors, right? I mean, that's if you've got two vectors interacting with each other. If you've got three, you got A plus B plus C equal D squared. A squared plus B squared plus C squared equal D squared. If you got three vectors interacting, because we're not necessarily like you could be driving down the road and you being the wind's blowing on you. That's one vector, right? And it could be a hailstorm. That's another vector. He hit by right? And then you have another person trying to run off the road. So you have to make multiple vectors, forces affecting you, what you're doing. See? And plus maybe somebody called you, so now you're trying to talk to them and try to drive. So, but I'm saying it's simple. So in other words, the more vectors you have, you put on the left side here, and you add more, and you do all this process in, right? You're going to get the result. They call it the resultant. After you put all those vectors together, what's the result of it? Okay. So here, this is called like a coordinate system. So I'll put this here because this usually tell you how a simple way to calculate vectors. It's a coordinate system here, right? So like 0 here, then 1 like a ruler. 1, 2, 3, 4, 5, 6, 9, 10, this way and up. So it's 3-dimensional. Well, in this case, it's 2-dimensional, right? See? So this is all positive. This is negative and positive here, this area. because you multiply times positive and negative numbers. This is all positive because negative times negative is positive, and this is again negative. This is negative, this is negative, this is positive, this is positive. We multiply two negative numbers together, it's a positive number. So minus 5 times minus 5 is 25. Same thing as 5 times 5. I know probably if you have no idea on math, that's going to sound confusing, but that's the case. Okay, so here, right? Trying to make it simple for you, brothers and sisters. Okay, see here? A squared plus B squared. See, now if you take this vector here, if you can see it here, right? And it's a triangle, right? And so you say if you take this one, this here, this side is squared. That's A squared. You take this side squared, right? It says you're going to get the area of this one. And that's a fact. It happens every time. Just check it out. You can use this here if you want to, because I got the exact, well, I moved that. Oh, I didn't mean to do that. Wow. Anyway, I got the exact dimensions here. I wanted to keep it in line with the graph here, right? So this would be, I'm using they call it a magic triangle because there's one that's 3, 4, and 5, and that's the only one like that, right? So I did keep it simple. So if this is 3 long this way, and 3, and that means 3 this way, right? If it's 3 this way, you square it. That means you get squared. That'd be 3 squared, and no, this would be 4 squared, and this would be 3 squared. The 3 squared is 9, 4 squared is 12. So 9 plus 12 is what? I mean, excuse me, 4 squared is 16. 16 plus 9 is what? 25. And this would be 5 here. So that'd be, this area would be 25. It works every time. Hope I didn't make a mistake. So here it is right here. Right? And this is 3. And this is 4. So this would be 5. That's only in the magic triangle, that one. Because if this was 2, and this was 2, then that would be, it would be 2 squared plus 2 squared, which would be 4 plus 4 is 8, right? Times square root of 8, which would be what this would be. So, I mean, that would be the line of this. But if you say that, okay, let me say it. If this was 4 and this was 3, right? Because the magic, this would be 5. So you say if this was 3, this would be 9, area would be 9. This is 3, area here would be 9. Area here would be, if this is 4, area would be 16. So you add this area together plus this area, that'd be 25. And if you took this area, that would be 25. Add these two together, you get that. Right? So. And see here, let me back up here for you. I don't know if you can see this right here, right? So here you go. I'm showing the vector here. Right? Next one. Okay, going that way. Okay, so what it's saying here is that I'm using the magic one, right? This is 3, this lined up. This is 3, this is 4. 1, 2, 3, 4. 1, 2, yeah. Right. If you check this sign, this would be 5. Right? So I'm saying if you have a force going this way and then a force going this way, this could be the result. That this would be the result, right, of those two forces interacting. So this person right here, if he's moving here, he's affected by this person, he's going to end up going this direction. The wind's course is going that direction because he's affected by this force here. He was going here, this force hit him, now he's going here this way. They're actually going that way together, but I don't want to go too deep into this. Oops, okay. Okay, I should have made stuff a little heavier, brothers and sisters, but anyway. Now, I don't know if you can see this or not. They're green, and it's not showing up too well here. But let me show it. Oops. Going too fast here. Okay. If you see it green right here, right? See, that's how you count. In other words, These vectors, this going by itself, these are gone. I should take that away. These are gone. But you're trying to figure out, well, what forces cause this? That's why I use this graph here. So you say, okay, what you do is you take this and take it straight down until you get on the same level as this. So, oh, well, this force here was 4. And then you take this till you get to that point. So that was 3. So now you calculate what this was that caused this. See, because you ain't gonna see this. This is all right. This happened. Now you get this result. And you don't see this anymore. All you see is the result. You see this car moving down the road, right? And it's going northeast instead of going north, right? So you say, okay, so you can calculate the forces, how much the wind was, how fast the car was going, and then what the wind was that caused it to go off like that. That's what you use a graph like this to do that. I don't know if that makes sense to you or not, brothers and sisters, but I'm saying you don't see this anymore. This is the force that he was driving this way. You got a force that was going northerly. He was going westward, and you got a northerly force, and now he's going like this. So you don't see his force anymore. So why is he going like this? Because you didn't know how he was going before, right? So you say, okay, let's go this. So you go in here and say, oh, well, now, okay. To get down to this point, it takes 4 and just 3. So you say, okay, well, then maybe looks like he was driving northerly and he had a west wind of a 3. He was going northerly at 4 miles an hour. Hope you understand, brothers and sisters. So here it is again, right? He's going this direction and hit by a north wind, and now he's going like this here. And so now this is going, you're going to try to figure out, well, how? What force is causing him to go in this direction? See? You're doing it right here now. Right? You do this down to the point where the line here and this here. You say, oh, this is 4, and this is 3, right? So he must have been going in this direction at 40 miles an hour, right? It's 30 miles an hour wind. So now, it's going like that. See what this has here. Same idea, brothers and sisters, previous. Think the same idea here. Okay, yeah. What I'm showing here now is those squares, right? I'm sure in this format. So this squared plus this squared equals that squared. Same, that's the same. I'm showing you a different way. Here's this one squared. Here's that one squared. And this. So if you was to add this and this together, you would get this. And so to shift around, you shift the vector around. You shift them around as long as you don't shift them the right way. So you go again. It's squared. It's wherever this was squared. So we know instead of using the magic triangle, this would be 4, this would be 3, and this would be 5. So 3 squared plus 4 squared will equal 5 squared. Besides for this, it's trying to show the mathematics, but it works every time. That's the way it works. Okay, going this direction, right? And okay. Okay, what's going on here? Move like that. It's the force acting like that. Okay, I'm not sure what I'm doing here. But oh, it's just showing you again. There's another way of doing it. You're putting it here to find out what this was. Once you do like this, this gonna be the opposite of this. Okay, you're going right here. Okay. These two forces cause this. Again, 3 and 4. 3 and 4 equal 5. That's just to make it simple, but if we use some much complicated ones than that, we have to go in and do some research. Okay, what's happening here? Well, like I said, you got two interact, and this is going to be resultant. Now, maybe you want that, maybe you don't. This is resultant. This is the way it works. It's going here, moving in. Here's the resultant. This is 3. Count it. This is accurate coordinate system. This 3, this is B4. So then you can figure out how far. There it is. Then this will be 5. If this is 3 and this is 4, this is 5. It's just a magic triangle or a magic vector, but say this could be 3, this could be 5, this could be 10, this could be 11, whatever. And then you say, well, if this was 11 squared plus 10, but it'd be 10, it'd be 100, 10, that'd be 100. So, let's say another way. If this was like a 5 or 10, or 10, well, say this was 7. This was 5. Well, this would be 49 plus 25. You have them together. That'd be 74. And it takes square root of 74, and that's what this would be. If you understand what square root is, right? Here you go. This force, of course, this. How does that affect us? Now say you go in this direction. This is you. You go in this direction. That's your nature. You move in this direction in life, right? And then you come in contact with something going contrary to you, a derivative of you. Now, another look, derivative, right? Okay, say you got the flats, right? So in other words, the floor. Say the floor is. You got the room, your room. You got to move around your room, right? Well, that's the third dimension, because you move around in it, right? And say like an ant on the floor, he's going to move around. If he's going to stay on the floor, he's going to move around the second dimension because he's on the floor. He's not moving up, right? He's only moving on the walls. He's not moving around. So he's only. That's a little exaggeration, but he's only living in the second dimension. He's actually third, but you know, he's so small. If you look at it, he's like a point, right? Say a spot. Say he had a spot on the floor, and that flower was moving around. Well, it's only second dimension. It can't move up or down. It only move along the floor, right? But if you got, maybe I should show this. But if you got, say you got a plate on the floor, flat, right? And you got a broomstick sticking up from it. Well, the plate would be considered, right? One dimension, because a plane, rather, 2-dimensional plane, because only actually 2-dimension. It moves sideways along the floor. Once it's on the floor, it's all good moves on the floor. But the broom can move on the floor and up. That's 3-dimensional properties. So the plate would be a derivative of the broom, in a general sense, right? Because one's 3-dimensional, one's 2-dimensional, right? So when you look at this, right, you're saying, see that the white one, this is only can move on that plane, right? It can't move up and down. You're gonna move on that plane. So it's two-dimensional. Let's say one-dimensional in a sense. I don't want to get you confused here, bro. So I'm gonna try use language don't confuse you. It just move along that line. Period. It can't move up or down. So say that's the second dimension right there. It's just moving along the floor. But you can move up towards the ceiling. So that means you can go through. You got another dimension. You can move higher. You can move to a higher level. You can move up to the ceiling. It don't even know a ceiling's there. All it knows is that floor. It moves along that floor. That's all it knows. It can't look up. It don't have the ability to look up, because then it would be. If you understand that. So right now, you have you moving along 3 dimension, and then you got a 2-dimensional being that kind of impacts you. See, and so now, because they're derivative of us, what happens? Oh, now you're going like this. See? Now, if this is longer, remember, the vectors, the longer it is, that means the more powerful it is. In vectors, the longer it is, the more powerful it is. I'm just using the simple ones, 3, 4, right, 5, because it's easier to calculate. But if this looks like this is 4, and say this is 3, so if that was 10, then this arrow would go down further, because the force would be greater. In other words, if you're going driving around in your car and you're going 50 miles an hour, and you got a 50 mile an hour wind from the westward, right? Then you're gonna go westward at a 45-degree angle. But if that wind's 100 miles an hour, you may be going all the way westward, right? Because the wind is that much more powerful. If it's strong enough, it's 100 miles an hour, right? Then you're going sideways altogether. You're not even going it. Hope you understand that, bro. So I'm trying to make it, but like I said, if this interests you, you got to go and look into it. But I'm just telling you how it works, right? So who do you blame for you going in that direction? Do you blame yourself? You was moving along this line fine, and then it's impacted by this. So who's to blame for you going this direction? See, I'm sure how it just impacts you. Who's to blame for you going this direction? Is it you or this wind here? Or this people, whoever, but this force here, is this the, because if you're talking about natures, you got this nature and you got this nature. And they're colliding. And so now you've been adjusted. Now you acting this way. When you was acting this way, now you're acting this way. Who's to blame for you acting this way? Is it you or this one? It's this one. Because if that wasn't, you'd still be going like that. See? I'm sure how it impacts you, plus it also impacts what's happening in reality, because a good controversy going on right now about this here. I'm saying Islam is mathematics and mathematics is Islam. Right? There's a big controversy going on right now, right? But we're sinful, we're wicked, and we were punished coming over here. We came over here because we were being punished. It's our fault that we're here. It's our fault we went to higher cause, right? God punished. We got to repent. You heard that before? That means, mathematics, right away, that whoever's doing that is a liar. Because the math tells you no. It says this was their fault. The ones boys over here, in their environment, this one's their fault. But this one, somebody's blaming you. That shows you either they're a liar, they maybe both. They don't know mathematics, or they're a liar, or they don't know mathematics and a liar. See, I'm saying when you understand, like I said about, when you understand about pressure, remember the collision? Remember the derivative? You know, you can't save the other one. Under pressure, as the pressure increases, you can't save the other one. Somebody tell, we're gonna be all together, we're gonna work together, we're gonna be all humanity, you're gonna repent, we're all gonna work together, love each other. That's not true. That's why I say back with physics again. That's not true. I mean, pressure again. That's not true. Hmm? And then when you go into a calculus, we're talking about derivatives, right? That tells you something right there too. It tells you, okay, if you're a derivative of yourself, then you, because you have, someone can be a derivative of you. Look just like you and everything, but be a derivative of you. Like artificial. Right? All these things, when them showing you the math behind this stuff. I tell you, it's all mathematics. So when you go in, you understand that a calculus for its derivatives. So okay, and that's what the grafted beings are. They're derivatives of us. That's what Scripture actually says. It says they have the image of us, but like without the I forget exactly how they say it. They're derivative of us. They're mathematical derivative. Then you understand that. You understand a lot of other things, and then you get here and you see, right, the blame game. See, if they're derivative of us, they ain't the same of us. They're totally different. They look like us. They ain't us though. They're derivative. And a devil, because they don't have the qualities of us. They'd be a devil to us because they're harmful to us because they're derivative of us. They can't keep up with us. We have a whole different, right? But if we in their world, they may control us. If we get in the derivative world, right? Then they control it because they're derivative people. But we can come out, they can't. So you get the derivatives, you get pressure, and back to the same thing again. They're derivative of us, collision, we not survive it. As the pressure increases, they cannot survive. It's the same. It's the same angel story. It's exactly what I keep telling you all this stuff is mathematics. I'm trying to give you a little taste of it now, right? But I can't go so far because you don't know. You still stumbling around with addition and subtraction. You probably don't understand what I'm telling you right now. But everything I just said right now, basics, explains exactly what I've been telling you about the angel, because it's all about mathematics. So in this case right here, you got somebody blaming us, and you know they're a liar. Right away, you know who they are. Right away, you know who the devil is. You know they're devils. They're not all you. They're not like us. See, Farrakhan said they like us. No, that tells you. Derivatives say they can't. They're not. That proves that derivatives, understand derivatives, you know it's the devil. Period. Understand? You know pressure, right? You know they're weaker. That's like the scripture, like the lesson say. They're devils and they're weaker. Wicked. That's where the word wicked comes from. They're wicked. And then here, they're to blame for our situation. But we're told that we're to blame. So that means it's a demon out there lying. See? There you go. No Farrakhan. It's them. They're the ones that's causing the problem. They're the one that's sinful. Because if we're sinful, it means they're the sinful ones. Because remember, if they're to blame, because we go in a direction, our direction change because of them, then we go back and do that to the vector analysis, find out what the force was that caused it. That means they're the wicked ones. That's why they have us going in the wicked direction. Okay? Where everything, all they cause now, they're going to look at us and say, that's them. That's who they really are. That's why I said I went backwards and show you. Once you see this, then you go into court and find out, okay, what force, I said, I'll explain to you. I said, okay, find out what force actually caused it. Let me go back to that real quick and then make sure you understand that. I gotta go back here, brothers and sisters. You got it here. Well, that's one way of doing it. Let me find a simpler way. No. Boy, I went too back too far. Almost there. Okay, here we go. And I said, okay, you have two forces and they cause this, right? Whoa. Two forces and they all cause, that's resultant. They call it the resultant, right? But now, the winds blow, right? Now these gone away. I should just disappear these two. They're gone because you see, all you see is the effect. You don't see the cause. You don't see the cause. All you see is the effect. So then you go and say, you go to your graph and say, try to figure out what the cause was. You say, oh, you had a wind going this way. Yeah, something going, a force going this way, and a force going this way, because that matches this. Then you go to the graph and get this. See, this is going. And I say, oh. So he was going this way and had a force going this way. So if he's going like this, right, this is what's causing it to go like this. This is the problem. This is what's causing it to go in this direction. He was going this direction, and this is the problem. So if he's wicked, this is the wicked that made him wicked. This tells you right? The forces. So this was a wicked force. If you're saying he's going in a wicked direction now, because this was a wicked force. Hope you understand that, brothers and sisters. So if you're saying that we wicked, we sinful and everything else, right? That means because we're around a wicked and sinful people, they blame us for it, like Farrakhan does, because he's one of them. The accused of our brothers cast down. So if we acting wickedly because we're exposed to a wicked people, that's why he goes. See, this is the force that caused it. But now these forces are gone. You don't see. All you see is the car going in this direction. You don't see the wind. You don't see any of that stuff, right? And then he said, well, why is it going in this direction? So then you go to the graph and do your function. Go and say, drive straight down to a line straight down to get to the bottom down here. Then so take a straight line to meet that. So oh, he was going this 50 miles an hour, and yeah, 30 miles an hour wind. See? But man, I'm going to close out, brothers and sisters. So here, you go back to the graph. So this is going. So you say, okay, draw a line straight down till you get to the bottom here. And say, how long is that line? Oh, that line's 4. And then draw a line from here till you get to here. So that line was 3. So he was going 40 miles an hour. He had 30 mile an hour wind. That's why he's doing that. So if you do the vector, if you say, so the bottom line is, if you knew that we was righteous people, and now we say a wicked people, we know we got hit by a wicked wind, a wicked people. If we was a righteous people, and now they say we wicked, we hoes, pimps, that kind of stuff, that means we got hit by pimps, hoes, drug addicts, whatever. If that's what we're doing now, that's what we got. That's what we got to think. That's what these people are. That's causing that. And what happens? If that wind stop blowing, then you start going in the straight direction again. So once you remove yourself from them or remove them, all of a sudden you're going to right there. So what's the answer? See, the answer is exactly like we was told. To get the hell out of here. I'm going to deal with that in my presentation today too. Get the hell out of here. But first, we ain't going nowhere. See, you expose everything I show you, expose to him. He's one of them. Because he's saying all the answers, he's saying to these questions. These is mathematics proving to you that Elijah was right. Proving to you, Master Muhammad is right. Proving to you that what Suleiman's telling you is correct. You check the math. All you got to do is check the math. You go get a book and check see if it's wrong or not. So he's telling you that's correct. So if that's correct, and it is, Farrakhan, you know that's supposed who he is. Because he's telling you stay here, where you, because he's one of them. He's telling, we are brothers. You see, we ain't. They ain't devils no more. Yes, they are. You understand, brothers and sisters? That's what I'm showing you this. See? I could show you a long time ago, but nobody wants to study, so there's a lot more. This is a lot deeper than I'm showing you. I'm taking this level right now, right? So maybe you get it, maybe you won't. What I just showed you right now, I just show you. Now you go and get a book and look at it, and I'm showing you the tool, how it applies to our situation personally, and how it applies to our situation as a nation, also how it applies to our situation as these people around here telling the deception that's around here. Because this cuts through all of it. It tells you exactly that Master Muhammad was the guy, Elijah Muhammad was correct, because he's saying the solution is that right, the solution, every solution he'll tell you to get away from him. Or he'll tell you to get away from him. And I'm going deeper than that in my presentation today. Right, so anyway, I'm gonna leave it there, bro, since I gotta be forever trying to get back. Well, let's see. I think I covered everything. The next one I want to do, I don't think I put that here. The next thing I want to do is, what's the next one I want to do? Vectors, calculus. I don't think I'm going to do trig. Neutrons. I'll get to atoms next, brothers and sisters. So I'm going to do, my next plan is, if we get to it tomorrow, probably not, if not today, because I'm going to do my presentation in a few minutes. But I want to get to atoms, then get to gravity. Hope you understand, brother. I'm going to leave it there. Assalamu alaikum. No, that's what we got. That's what we got to think. We can check see if it's right or wrong or not.